Assalamu alaikum everyone. Today you will learn about difference operators. I'll teach you 5 difference operator in this lecture, and then we will also study about the relationship between these relation. So first, as you know, it's shift operator. Some people also call this shifting operator, and the symbol of shift operator is E, and it is defined as, that's how it works. If we apply the shifting operator on f of x, then it becomes f of x plus h, which means there is an increment in h after applying the shifting operator. In the same way, if this is e square f of x, it will be like e and then e f of x. Shifting of when we apply shift operator on f of x, it becomes f of x plus h. And finally, when we apply shifting operator on f of x plus h, it becomes, there is an increment, so it becomes f of x plus 2h. That's how it works. In the same way, it also, there is if you apply a shifting operator on a function, there can also be decrement in that. For example, like if we apply inverse e negative 1, there is a decrement by 1 unit, like f of x minus h. In the same way, if it is like e negative 2 f of x, there is decrement by 2 units, which means x minus 2h. Now if the power of, if it is in fraction, it will work the same way, like f of x plus h by 2. So this is our shift operator or shifting operator. Now the next one is forward difference operator. The symbol of forward difference operator is del, and it is defined as, if we apply forward difference operator on f of x, so it becomes f of x plus h minus f of x. That's how it works. For second order forward difference operator, let's see how it works. It's like del and then del f of x. We apply forward difference operator on the function, so it becomes f of x plus h minus f of x. Now we will apply forward difference operator on the functions. So first we will apply on this and then on this, so it becomes f of x plus h. Let's do it separately. First it will apply now f of x plus h and then del of f of x. So this become, by following this, f of, since it was x plus h, so it becomes x plus 2h minus f of x plus h, and this becomes f of x plus h minus f of x. So by simplifying this become minus 2 f of x plus h plus f of x. So this is our forward difference operator, and that's how it works. And now backward difference operator. Its symbol is this, the opposite of del, and we can also say like nebula or something. So, and it is defined as, if we apply backward difference operator on f of x, it becomes f of x minus f of x minus h. We can find the backward difference of like y1. This would be, we know that y1 is equal to f of x1. So now we will apply backward difference operator on f of x when in the same way we applied on x. So this becomes f of x1 minus f of x1 minus h, and then f of x1 minus f of, we know x1 is equals to x naught plus h. We have studied this in the previous video. So it becomes x naught, and f of x1 is equals to y1 minus f of x naught is equal to y naught. So backward difference operator of y1 is y1 minus y1 y naught. We can easily tell like what is the backward difference operator of y2. It is y2 minus y1. And the next difference operator is central difference operator. Its symbol is delta, and it is defined as like central difference of f of x is f of x plus h by 2 minus f of x minus h by 2, which means the half of h by 2 h by z is central difference operator. You only have to remember this formula because this is very important. We will use it in other proofs. So you just have to remember this formula. And the next operator is averaging operator. Mostly we use forward difference and backward difference. Averaging operator, its symbol is mu, and it is defined as if we apply average operator on f of x. So this become like average half 1 by 2 f of x plus h by 2 minus f of x minus h by 2. So that's how it works. If you appreciate my work, please like this video, share, comment, and subscribe to my channel. And in the next video we will study the relationship between these operators like mu, differential, and this forward difference operator, etc. Thank you so much.